Lesson 1.6. Yay! You got here, you made it, you're awesome. We're now going to put it all together. Hence the title, Let's Put It All Together! We should put some exclamation marks. Boom, boom, boom. Bigger ones. And fill it in and color. Mr. Nicanor can't color between the lines. Here we go. Just like that. How awesome is this? Let's put it all together! From everything that you've understood about creating tables, finding patterns, and using expressions, and solving equations, let's put all that stuff together now. Turn with me to page 24. Lesson 6, solving problems using patterns. Let's zoom this in. Now, we've got our goal today, which is identifying and using patterns to solve problems. That's going to be our big goal. Identify and use patterns to solve problems. And what we've done in the past 4 or 5 lessons is we've been doing this already, and now we're just taking it a step further. Okay, let's go to our question. And remember, word problems have 3 things. Can you tell me? The introduction. 2, the information. And 3, the question. Some like reading the question first. So if you want to read the question first, it says, how long will it take until the 2 classes meet on the trail? Okay. How long will it take for the, how long will it take until the 2 classes meet on the trail? 2 classes meeting on trail. Let's see. There's a pretty picture here. Ah, how pretty. There we go. I envy this guy. Why? Because he's got hair. I digress. Let's move on. Now, the first part of every word problem is that it has an introduction. And here's the introduction. The students in a grade 6 class are starting to walk east along a 30-kilometer trail. They can walk about 4 kilometers each hour. Okay, there's some information in that introduction as well. So let's break down some of these numbers that we should know. In the grade 6 class, okay, they're starting to walk east. They're walking east, so that's east. Typically it's east because if north is top, then east is right. Along a 30-kilometer trail. Okay, so they're walking 30 kilometers east on a trail. They can walk about 4 kilometers each hour. Interesting. So now we've got some information. If they're walking east, right here, they're walking east along a 30-kilometer trail, every hour they walk about 4 kilometers. So here's some more information. The students in another class are starting to ride bicycles. Whoa, hardcore. They're riding their bicycles west along the same trail. They can ride about 6 kilometers an hour. Ooh, la-di-da. They can go 2 more kilometers an hour. I'm with the walking guys. I can't afford a bike. Okay, so they can ride their bike 6 kilometers each hour. Now, this question now makes sense. How long will it take until the 2 classes meet on the trail? Can you find an expression that would be able to solve this and create an expression to solve this? That's just a little extra if you want to. We have a student here that has taken the time to solve this. So here's Robin's understanding of how to do it. If you want to try and find out before going through Robin's solution, why don't you press pause and figure it out now? Okay. Now, let's understand this. When the 2 classes meet, the distances they've traveled will be about 30 kilometers. Is that what you got? If so, awesome. If we color, let's get green. Here's the walking distance that we have here, and here's the riding distance. And the whole trail is 30 kilometers. Robin said, I have figured out how long it will take until then. First thing she did was make a plan. She says, I'll make a table of values to show how far each class travels every hour and how far both classes travel in total. I'll look for a pattern I can use to solve for the problem. And now she makes her table of values. Ooh, that arrow. Look at that arrow. Going all around the world. Okay, we got to erase that arrow right there. It's kind of distracting. Okay, erase that arrow. Boom. And let's go with carrying out the plan. So she's got in her table of values her title. Dun 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 dun. Check. Then she's got her columns and labels. So she's got time, check, her first column. The walker's distance is kilometers. So remember, her expression would be 4 kilometers per hour. So every hour, it would add to 4, 8, 12, 16, because every hour she's adding 4. Okay, let's just get rid of those lines. And then over here, we've got the biker's distance per hour, and they travel 6 every hour, right? So 6, 12, 18, 24. Now, the total distance right here, the total distance in kilometers per hour. The way that she solved total distance in kilometers per hour on this side is she totaled the number of kilometers traveled by each group. 4 plus 6 is 10, 8 plus 12 is 20, 12 and 18 is 30, 16 and 24 is 40. Now, because of that, she was able to come up with a pattern. And right here, she talks about it. There's a pattern in the last column. Together, the walkers and riders traveled 10 kilometers each hour. They meet after 3 hours when the total distance is 30 kilometers. So if we know that in 30 kilometers, they've totaled the total distance of that trail, the walkers traveled 12 kilometers and the bikers traveled 18 kilometers for a total of the entire area. So we can write here that the walking distance was 12 kilometers and the riding distance was 18. And the whole trail took 30 kilometers. We know that the walkers walked a little bit slower, covered less ground, and the riders covered more ground. So this ground that they covered right here was 18 kilometers, and the small distance traveled by the walkers was 12 kilometers, giving a total of 30 kilometers for the entire trail that was traveled. Is that something that you got? Awesome. You're going to do fantastic. Talk to you soon.